example how we could do this. Okay, say you have 20 kids in your class, okay? And we want to maybe figure out, if we're ordering pizza for everybody, we got to kind of figure out how much of each type to order. But we don't want to talk to all 20 kids, okay? So maybe we just do a sample of 5 kids, okay? So there's a couple of vocabulary words in this section. First of all, the first word is population. So the population is everybody in your class. So you could say the population was 20. Okay. Now the sample is just a small part of that population. So the sample that I chose to ask would be 5 kids. Okay. It's just a small part of the overall population. All right. And we can use population and sample to help make predictions using probability. Okay. So say I talked to those 5 kids. And of those, I gave them the choices: pepperoni, hamburger, and cheese. Okay, I talked to those 5 kids. Well, 2 preferred pepperoni, 1 preferred hamburger, and then 2 preferred cheese. Okay, so I'm going to go ahead and make a probability here, okay? So out of the 5 kids, 2 preferred pepperoni. So what is the probability that what's the experimental probability that they will choose pepperoni? Well, I've got a 2 out of 5 chance kids will like pepperoni. Okay? Now how can I apply that to the bigger group? Okay? Remember, I'm trying to use this to help make a prediction about a larger group. Okay, so if 2 out of 5 from my sample like pepperoni, well, we've talked about proportions. We're going to make a proportion now. All right, so 2 out of 5, well, what is that over 20? So if I use the 2 out of 5 in my sample, what number is that then over 20? Well, in this case, we know how to solve proportions. We've done the cross products. We don't need to do cross products here, do we? Because we know 5 goes directly into 20. So we do 5 times 4. So then what do we do to the 2? 2 times 4. All right. So that tells me then chances are then 8 kids out of the 20 are going to like pepperoni. Okay. Well, let's do the same thing with hamburger. Okay. So what fraction of the sample likes hamburger? 1 out of 5. Okay. So let's go ahead and apply that to the bigger group. Okay. Well, 1 out of 5 likes hamburger from our sample. So let's apply that to the total population. Okay, so again, don't have to do cross products. Times 4 times 4. Okay, so then that tells me 4 out of 20 are probably going to order hamburger. And then cheese we don't really need to do because we figured out it's going to be the same as the pepperoni. All right, so let's go ahead and apply this to a larger scale. Okay, so say I'm just going to work through one from the book. Okay, so all right, so they say a company makes shirts, pants, belts, and socks. It makes 24,000 of each item. Okay, so I'm going to just jot that down because I think that number is going to be important. $24,000 of each item. Okay, for each sample, predict the number of items likely to be defective. Okay, so for the first one, they say, okay, well, out of shirts, there were 6 defects out of 500 shirts. Okay. All right, so let's think about our vocabulary again. Okay, so what's the overall population? This company made 24,000 shirts. It made 24,000 socks. It made 24,000 pants, whatever. Okay, so the overall population, well, there's 24,000 shirts floating around. Okay, now the sample are these 500 shirts that they just randomly pulled, and out of those 500 shirts, they had 6 defects. Okay, so we're going to use this. We're going to figure out the probability that there's of getting a defect, and then we're going to turn around and apply it to the overall population. Okay, so let's write that as a fraction. We've got 6 defects out of 500 shirts. Okay, so that is the probability that there's a defect. Okay, well, let's go ahead and simplify that. So 6 defects over 500, well, we know they're both divisible by 2. So that's going to be 3 out of 250. Still kind of big numbers, but it's all right. All right, so I got a 3 out of 250 chance that my shirt's going to have a defect in it. Okay, now how do we apply this to the overall population? Remember, we set up our proportions. All right, so our overall population is on the bottom, okay, because this is how many out of 250, and we want to figure out, well, how many out of 24,000 are going to have that same defect. So we put our variable there. All right, now I don't even want to, I'm reasonably sure 250 does not go evenly into 24,000. So we're going to go ahead and do cross products. Okay, so we should remember how to do this. All right, so we've got 250x is equal to, well, 24,000. I really shouldn't have to work this out, times 3, 0, 0, 0, 12, 72. Okay, so now my problem is 250x is equal to 72,000. All right, so remember with cross products, what's my next step? Okay, got to use my algebra. Divide by 250. Poof, it's gone. Divide by 250. All right, yikes. Okay, well, let's divide 72,000 by 250. Can you see that? Okay, yeah. All right. Okay, so long division. All right, 250 doesn't go into 7. Nope. 250 go into 2. Nope. Or 72. Nope. Does 250 go into 720? Yes. How many times? Twice. Okay, 2 times 250, 500. That is 220. All right, so now we need to bring down that first 0 there. How many times does 250 go into 2,200? 8. Because I know 250 times 8 is 2,000. All right. Bring down that other 0. All right, well, 250 goes into 2,008 times. So my answer, using this probability, out of 3 out of 250 shirts sampled were defective, I can predict that out of 24,000 shirts, there's going to be 288 shirts also defective. All right, let's just do one more. I know, this is good times. All right. We're going to keep with that same company that makes 24,000 of each clothing item. And we'll do belts. Okay, so again, we're at 24,000 items. Or in this case, we're talking belts. Okay, so now we're told out of 250 belts sampled, 2 were defective. So again, total population, 24,000. That's all of them. Okay, sample size, 250. Okay, so we're going to use the smaller sample size to make, to use that to make a prediction that we can apply to the larger sample. Okay, so 2 defects in 250 belts. Well, let's go ahead and set that up as a fraction. All right, we can simplify that. 2 over 250. Okay, I know that is 1 over 125. Okay. We're going to make a proportion. Now, 1 over 25 is proportional to what number over the total population, which is 24,000. All right, so do my cross products. So 125x is equal to 24,000. Okay, well, let's go and solve this. Divide that by 125. That's once. 115, drop that 0. Oh my gosh. Well, it will go in, well, 125 goes into 250 twice, and I know 4 groups of 250 goes into 1,000, so that's 8. Let's add 1 more, that will be 9. And that will give me 1,125. Okay, so that leaves me 25 Drop in the last 0, 2. Okay, so out of 24,000, I can expect there to be probably about 192 belts that are defective. All right, so good luck with this assignment.